Okay, it'd be great to start. If I can, the first question I can ask is how does structured cabling impact latency when it comes to AI GPU clusters, which is obviously, AI is the flavor of the month, shall we say, or so yeah, in terms of structured cabling impact latency, AI GPU clusters compared to point-to-point cabling. What, yeah.
Well, there is, it is the buzzword at the moment, AI. There's no doubt about it, and there's some great companies building some fantastic networks out there. And we have noticed conversations where certain groups have felt a strong concern that going down a structured cabling route, as opposed to what a lot of the pod builders are doing, which is a point-to-point, which is connecting the server directly into the leaf switch, is all about. There is a concern that adding more optical connectors will introduce latency. So look, we decided we don't believe that's the case. So we went away and looked at this and actually did some testing, Phil, where we built in some optical connectors into these various channel lengths. And what we found was, because these AI pods are typically operating at around that 50 meters, some of them are even smaller. There are one or two that are a bit larger. There is no big concern on the latency front, primarily because the optical fiber latency drive at those sort of very short lengths, you're looking at probably about 250 type microseconds. Now, when you start to look at forward error correction, frame buffering, and queuing in the actual design of the network, that's the area that does add a lot more latency. So the architects are crucial in these AI pod designs, and that's why they're super intelligent and super brainy, because they build a network structure that reduces the number of hops from server, leaf, to spine, back to server again. That's where the latency occurs. Introducing a couple of optical connectors, what we found from our testing, doesn't actually impact on latency. And this can be seen from the IEEE, who have, in 2024 launched within 802.3 DF a sequence of testing parameters where they actually allowed certain amounts of optical loss within the actual channel for 800 gig. So we took that channel sequence, built it into our lab, brought in a lot of these QSFP chipsets from the likes of NVIDIA and some other providers as well. And we actually found that these GPUs were actually very, very strong units. They performed extremely well to 802.3 DF. And as a result, our analysis showed that there is optical budget headroom in these channel sequences. So adding a little bit of optical loss does not in any way, shape, or form impact your latency. And we have shown that, we have seen that from the data. So we feel pretty comfortable that there should be no concerns in terms of latency when it comes to adding the right amount of connectorization to give you a structured cabling system.
Okay, I mean, then I guess it would be good to carry on and ask, what are the operation and logistical benefits when it comes to structured cabling in managing these, these high density AI pods, which you've been talking about there?
So parts of the reasons we did that study was for this exact point. When you go down a structured cabling route, we tend to find it's much simpler to deploy, Phil. There's no two doubts about it. Troubleshooting is a lot easier. When you go point to point, you have to allow a good degree of slack to be able to traverse from, potentially the bottom of the server cabinet right the way through to the top of that cabinet, into pathways across through to other cabinets where the active components are housed. So you have to have a good amount of slack. So slack management is always a problem when you're looking at the point-to-point effect. Whereas when you go with a structured cabling deployment scenario, you tend to use much shorter patch leads because you're going into a patch panel. So controlling that look and feel is a lot more secure in a structured cabling environment. Inventory management is a lot simpler as well. These speed of deployment is absolutely huge with every single pod we've worked on. So if we can make 1-2 meter MPO interconnects, it's a lot quicker for us to turn those around than making 10, 15-meter interconnects, and your inventory management is a lot simpler with a structured cabling approach. So from our perspective, those are some of the operational benefits that we've seen going down this particular route.
Okay, and I guess one of the other things with the sort of AI landscape is the sort of uncertainty as to where it's heading. So I guess it'd be good to understand the ways in which structured cabling can improve scalability and also the sort of future proofing for these AI data centers.
Well, from our perspective, it's an approach that if you're going down an AI pod road, the turnaround with these GPUs, we've seen, kind of like 12 to 18 months, faster, better units are coming out. So that means reconfiguring servers, reconfiguring networks. And with a structured cabling approach, because everything is self-contained within that cabinet, and you're using a very, very simple approach, as I described earlier, where you're using two 1-meter patch cords to go from server to a patch panel. Should you need to reconfigure and change, it's a lot easier to manage that. And that's one of the key impacts that we have. So again, that support of that quicker turnaround, the ability to understand what's plugged in from server to leaf, port to port, because you are using a system that has the ability to get labeled, color coded, just makes it a little simpler. We can give visual cues to be able to allow people to see and operate in a lot simpler and easier fashion, especially when you're looking to future proof, because if you have lots of changes coming through, typically a pod that you would want to have running, maybe 5 to 10 years, but your refresh cycle on served GPUs, maybe 12 to 18 months, you want to make sure you're using that infrastructure that you've implemented. You don't want to be changing out or having to replace the whole support structure. You just want to change the active components and use the support structure that's there for future upgrades.
Okay, and I suppose another potential sort of concern for folks is, structured cabling. Is it more expensive than point to point? And if it is, can you sort of justify that? And I guess with the sort of capex and opex, but just talk us through the maths, if you like, of the two options.
Good question. Look, if you add more connections, there is a small incremental uplift in cost when you come to putting in more optical connectors in there. There is no two ways about that. But what we found is that with that extra uplift, which is small compared to what you're looking at when it comes to the cost of these GPUs and the servers and leaves spines that support them, what you find is that improved deployment speed that I described, you can rack and roll. So we have certain scenarios where we're pre-configuring infrastructure above those cabinets in a structured cabling approach. So effectively, these pre-configured cabinets are coming in and just being deployed at very fast turnaround times. So the speed of deployment aids that structured cabling approach for a little bit extra on the actual componentry. You're looking at reduced congestion, better slack management, so that there is a general improvement in terms of the look and feel and the workability of that particular system. And don't forget, if you're looking at reducing the lengths of those point-to-point links to shorter patch cables or patch links or 1 to 2 meters, there is a reduction in cost in that area. So overall, there is a small increase, but it's not the big concern that we've seen out there in the marketplace.
And maybe just one sort of final area that's of interest. It'd be good to understand the role that structured cabling plays in supporting emerging network topologies, maybe something such as rail optimized GPU architectures. What are the opportunities for structured cabling in those sort of environments?
Well, I mean, the really cool bit about that rail optimized architectural deployment piece is ensuring that the way it's configured helps to improve that latency topic that we talked about right at the start. So, you have the traffic from, say, server port GPU 0 being directly linked to leaf port 0 or a particular leaf switch. So every single server in that architecture, GPU 0 will come to that leaf switch. So you will have all GPU zeros in all the servers coming to that particular leaf switch. And what that allows you to do is take shortcuts within the architecture system so that you can avoid hops within your network. when you go to a structured cabling approach, and when you have the ability to identify and label and document, create a working database of what's patched to where, which we have with a system we have implemented on all our interconnects, trunks, and patch cables called Rapid ID. If you're looking to document and ensure that if you're then reconfiguring and changing anything, you have a database of what's patched to where. And that's really super important with these rail optimized systems, because you need to make sure that all of those GPU port zeros on every single service, bearing in mind there might be 8 GPUs within a particular server frame sequence. All of those GPU zeros have to be patched into the right leaf switch. So documentation, good records, absolutely critical within these environments to ensure that the architecture that's being designed is what is physically implemented within the actual pod itself. So that's an absolutely key area. It gives you good visual verification. Structured cabling does that in its essence. Super topology awareness in terms of the ability to have a complete database of what's patched to where. So it's a strong approach, and again, just reducing that cable density, because what we found is the number of cables, Phil, within these environments seems to just be going in one direction and that's up. So having the ability to have less containment above your pods, having the ability to have less cable management issues within your cabinet is super important. And that's what a structured cabling system gives you.
Excellent, thanks for that. And if it's okay, as I've got you here, just be good before we finish to
Yeah.
ask. There's been a couple of launches that I think I've bumped into recently. So I think you've launched 2 fast, high volume thermal transfer desktop printers, which perhaps you can tell us a little bit about those. And also, I think there's was it the RJ45 Keystone module? So perhaps can you just give us a little bit of an overview of those, recent introductions, if that's okay?
Yeah, sure. So the Keystone modules, we brought into the marketplace so that we would be able to offer a good enterprise type solution within some of our existing client base. So it's something that fits into a Keystone outlet, a Keystone jack. So where you do have the need for, in some executive suites, fascias have to look and give the right impression, that Keystone module fits into that very, very simply, which works very, very well. So it does allow us within the enterprise market space to be competitive in that particular aspect. The thermal printers, always a good idea. Labeling, documentation is absolutely key. And the features of these thermal printers are very, very fast deployment of labels. And the usability of these labels is critical. You can imagine in these environments where we are looking now, Phil, of the talk is all of 75 watts, 75 kilowatts, I should say, within a cabinet and above. We have some future GPUs talking about 600 kilowatts in a cabinet. Now, I'm not saying that you're going to have that amount of heat coming out of the back of the cabinet, because these are all liquid cooled chipsets. So the heat requirement is going to be vastly reduced, but they're still going to be warm in that environment. So these thermal printer properties and the labels have good heat capability properties, so that they can be in the back of these environments, labeling up everything fully and not worrying about, quite frankly, Phil, in the past, what we've seen is when you start to raise the temperature in these environments, labels start to fall off. You cannot lose the ID within that environment, because as we discussed, it's absolutely critical. Whatever you're doing, whether it's point-to-point or structured cabling, a good labeling system is absolutely key, so that you know what's patched to what.
Okay, and maybe just finally, in terms of anything you can share for the Panduit, the roadmap. Is AI your sort of main focus? As I say, the whole world is, I won't say they're obsessed with it, but it's clearly dominating the space at the moment. Is that what you're looking at, or are there other things that you can share as to what you're planning, where you're going?
No, it certainly is a big focus for us, because there is just a huge amount of volume there, Phil, and it's very difficult to ignore that as a business. So we are working very, very strongly in that area to look at how we can give people the ability to have good record keeping, give people the ability to manage these very, very dense environments. So we're going to continue to focus on that server to leaf spine architecture topology to get the best connectivity that allows these pods to be deployed. And quite frankly, Phil, we're being pushed to deploy faster and faster and faster. So speed of deployment is absolutely key. But apart from that, we have to have a broad set within the business objectives that we have. So the data center is a key area. Connected buildings and enterprise is absolutely key for us as well. So not only do you see AI within the data center environment, but within a connected building, these intelligent buildings have a huge amount of intelligence built into them, which is also artificial as well. So we are looking at ways of how we can look at the design of these buildings to try and improve the efficiency of the delivery of power. So more on that to come within the marketplace as we grow, because if we can get on our structured cabling systems, on our design deployment systems, incremental improvements in the use of power within buildings. You can imagine looking at the great cities we have across the globe. If we can give 5% savings based on the structured cabling system you choose, if we can give you 20 to 30% power savings based on the architecture and the design you choose within an intelligent building, that's absolutely key. So we're doing a lot of work in that area. And let's not forget a huge aspect for us as well, which is taking that intelligent building and a structured cabling system in there and ruggedizing it to look at the industrial element as well. So from our perspective, covering that industrial base is hugely important, because the best ways you can get security efficiencies is looking at collapsing those disparate networks that you have in intelligent buildings and industrial systems, where you have BACnet protocols running, LAN protocols running. We're seeing a trend to the collapse into an Ethernet protocol framework, and that gives you better security because everything is running on one set of switches, one set of protocols, so that you can manage that. And the move into that area where we're ruggedizing the connectorization we have from a structured cabling point of view to support the industrial element is also a huge part of our business. So we're seeing a massive change and a massive movement in terms of automation, in terms of collapsing into architectures, in terms of that push for latency as we talked about within the structured cabling environment. But we have to manage and be an octopus and have lots of tentacles and lots of different pies, and we're trying to drive in that particular area. So for us, data centers are hugely important, but there are other parts that we must not ignore because we do so at our peril. So
No, that's great. I mean, it's been brilliant to chat to you, and thank you so much for sharing your insights into what's going on, obviously in the sort of AI-driven data center, but also the insights into some of those other areas. So, Michael, really appreciate your time. Thanks so much.
absolute pleasure. Lovely talking to you, and thank you again.